Okay, moving on to question 14. So we have a spinner. The spin is being cut in 6 equal pieces. We have A, B, C, D, E, F. And they are also numbered 1, 1, 2, 2, and 3, 3. So A, what is the probability of A? It will just be 1 out of 6. Because one of the region is A, and out of 6 equal region. Probability of getting a 1 is going to be 2 out of 6. Because both A and B are number 1. So we can simplify that to 1/3. Probability of A or C. So A is 1/6, C is 1/6. So we just add them up to get 2 over 6. And 2 over 6 is also 1/3. D. Probability of a 1 or C. So we see that A and B are both 1. And C, there is only one region. And this is out of 6 total region. And we can simplify this to a half. E. Probability of both 1 and A. So 1 and A, there is only one region, and that's 1 out of 6. And that's it for question 14. Moving on to question 15. So this is the 3 children examples that we went over in the concept videos. So family has 3 children. The first child can be a boy or a girl. That's the first child, or the oldest child. Second oldest can be a boy or girl. And finally, the youngest can also be a boy or girl. So now we can write out our sample space is boy, boy, boy for this one, and then boy, boy, girl, boy, girl, boy. So you can kind of like go back to the branches to figure out what it is, right? And then the next one is boy, girl, girl. And then girl, boy, boy. Girl, boy, girl. Girl, girl, boy. And the last one is girl, girl, girl. 1, 2, 3, 4, 5, 6, 7, 8. So we should know that there are 8 possible outcomes. Because remember, if you use the shortcut, it will just be 2 times 2 times 2. Because for each of the child, they can be either boy or girl. So there should be 8 total possible outcome. And that's exactly what I have here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so A, probability of all girls will just be 1 out of 8. That's the only one with all girls. All girls or all boys, it will be 1 out of 8 plus 1 out of 8. Because it can be boy, 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 or girl, girl, girl. So that's 2 out of 8, or 1 over 4. Exactly 2 boys. That's 2 boys, 2 boys, 2 boys. And that's it. So that's 3 out of 8. Exactly 2 boys or 2 girls. So exactly 2 boys is 3 out of 8. And exactly 2 girls. That's exactly 2 girls, 2 girls, 2 girls. So 3 out of 8 plus 3 out of 8 is 6 out of 8. And we get 3 out of 4. E. At least one girl. You know, at least one girl is really just 1 minus no girls. If if you think about 1 minus probability of no girls, it would just be 1 minus probability of boy, boy, boy. That's the only case to have no girls. So that's 1 minus 1 over 8. And our answer is 7 over 8. And F, at least 2 boys. 2 boys, 2 boys. And 3 boys is also at least 2 boys. 2 boys. So that's 4 out of 8, or just 1 over 2. So whenever there is more than 3 or more events, a tree diagram is definitely very helpful. Okay, moving on to question 16. A game is played with a pair of dice. $1 is spent on either rolling over or under 7, and you win. You receive another $1. If you lose $1. If $1 is spent on rolling a 7 and you win, you receive $2. Okay. So again, we are just rolling 2 dice, so we need the two-way table. Dice number 1, and dice number 2. And then you just add it up, right? Because we are still looking at the sum. So A, what is the probability of getting under 7? Well, it will be over these. These are all under 7s. So that's 5 plus 4 plus 3 plus 2 plus 1. So this is how I got 5. I have 5, 6. That's under 7. And then 4 5s. Right? And then 3 4s. 3 4s, 2 3s, and 1 2. Okay, so that's how I got these 5 plus 4 plus 3 plus 2 plus 1. And this is over 36 total possible outcome. So that's 15 out of 36. And then B, the probability of getting 7 is just 6 out of 36. So is this a fair game? It will be no, because your chance of winning is less than 50%, right? So what I mean is if you bet under 7, your chance of winning is 15 over 36, which is less than 50%. 50% will be 18 out of 36. I forgot to simplify that. And same with just betting on 7. Even if you make $2, your chance of winning is so small. It's only 1 out of 6. It's not fair. Okay, so let's move on to question 17. A black die and a white die are thrown together. Determine the size of the sample space. You know that already. It will be 6 times 6 is 36, right? We have been looking at these dice problem many times already. The number of black equals to the number of white, so that's your double. That's the probability of 1, 1, plus 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So that would just be 6 out of 36 or 1 out of 6. The number of black greater than the number of white. I can make a two-way table. So I will just use gray for white. So the first number represents the black dice, and the second number represents the white dice. Okay, so the black greater than the white. This one, black is greater than white, black greater than white, right? These 3, and then these 4, and these 5. So that's 1 plus 2 plus 3 plus 4 plus 5 of 36. And if we simplify this, we get 5 of 12. If you win when the number of black is greater than the number of white, is this a fair game? So again, it's no, because my chance of winning is less than 50%. So you see, if it's a fair game, your chance of winning should be exactly 50%. And if your chance of winning is more than 50%, it would just be a favorable game for you to play, because you will always, well, not always win, but in the long run, if you always play this game, you will end up winning more than losing. And that's actually how casino makes money. Okay, so 18 and 19, I don't think it will be tested. So for question 18, they want you to flip a coin 100 times. And then you need to count the number of heads and tails. So we can achieve this with a stimulator. Flip a coin. So I mean, you can do it like you can flip, and then that's a head, right? You can do it 100 times, or yeah, actually this one is, I want to still, maybe just flip a coin 100 times, just like that. Yeah, let's try just 100 and then flip. Oh, value must be less than or equal to 50. Flip. So we can flip 50 coin all at once. And then I can record the number of heads. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I have 27 heads, which means tail will be 23 because they have to add to 50. And then I can just do it one more time. I'll flip again, and then I'll just count the number of heads. Right, head is the one that is showing a person's head. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 26 heads. Which means tail must be 24. Right, so again, definitely not something that you will get tested on. But what I'm trying to show you is that you will see that the probability is quite close to what we have been always assuming. Right, so we are pretty close. The probability of head here is just 53 over 100, which is 0.53, right? In theory, we would expect them to be a 50-50, so 0.5 each. So it's pretty close, right? Roll a dice 180 times and record each outcome. How close are you to the theoretical value? So again, you can do this with a stimulator, definitely not going to be tested. So in theory, your probability of getting a 1 and 2 and 3 and 4 and 5 and 6 should be just 1 out of 6. So, the more times you do it, the closer you are to this theoretical value. Okay, that's the end of 7.6. I'll see you in 7.7.